Hello everybody, and welcome back to Azure ML for Beginners. In this tutorial, we're going to walk through how to use Studio for the first time to create a machine learning experiment. So the first thing I'm going to do is log into my Studio account. And for this experiment, we're going to use one of the data sets that Microsoft has pre-uploaded into Azure ML Studio in its library. So the whole concept behind it is trying to predict the value of a product based on its features. So for this specific one, we're going to use data set related to automobiles, and the whole point is to predict what price to sell an automobile at based on the features that are within it. And this can be translated to any product that you are trying to sell or you're trying to go to market with. So let's say you've developed a specific product and you're trying to figure out what price point to release that into the market. So this can help you decide what is the optimal price point based on the features and based on other variables that you can use instead of these variables that we're going to look at in this example. So basically in this experiment, we're going to look at the 5 main steps that are involved to build an experiment to create, train, and score our model. So the first step in performing any experiment is getting the data. So there are several sample data sets included within Studio, and like I mentioned, we're going to be using the one that's specific for automobile price data. So the first thing we're going to do is click on New on the bottom left hand, and we're going to start a blank experiment. Now the experiment is given a name by default, as you guys can see up here, and we're going to change that to automobile price example. So on the left hand side, you guys can see these are all of the different options that we can use when we're designing an experiment. So the first thing we want to do is get the data. I'm going to click on Save Datasets, and you guys see a couple of examples. First one is my dataset, so anything that you've pre-uploaded yourself or you've used previously will show up here. And again, if you click on Samples, this will give you all of the samples that are pre-uploaded by Microsoft. And the easiest thing is just doing a search on top. So I'm going to search for automobile, and here we go. So we have the automobile price data. I'm just going to drag that out into the experiment field. Now once it's there, I can also see what the data actually looks like. So if I right click on it, I can go to Dataset and Visualize, and this will give me a visual depiction of what the data set actually is. Now just a tip, datasets and modules have input and output ports represented by small circles. So this one you see one small circle here as an output. So to create a flow of data through our experiment, we'll need to connect an output port of one module to an input port of another. At any time, we can click the output port of a dataset or a module to see what the data looks like at that point in the data flow. So again, for this specific dataset, what we're trying to do, or what we're trying to ultimately predict, is the price, which is the last column that you guys see here. So this is what we're trying to predict based on the historical data that we've uploaded in this data set. So the next step after uploading the data is preparing the data. And most data usually requires some pre-processing before it can be analyzed. For example, you might have noticed some missing values in some of the columns. Just to give you guys an overview, if you go back into the data, we can see that this normalized column has many values that are missing, which might skew our data, which might skew our predictive analysis. So we're just going to remove this altogether. So the first thing we're going to do is add a module that removes the normalized losses column completely. And then we can add another module that removes any row that has missing data. So again, what I'm going to do is I want to select columns. If I just expand this, you guys can see what it looks like. So we have two options in data manipulation: select columns in the data set, select columns transform. So I'm going to select columns in the data set and just drag it out here. And if you click on it, on the right hand side are all of the properties for this specific select columns in the data set experiment module. Launch the column selector. What we want to do is exclude column names. So as you guys can see, I've excluded the column by the name of normalized losses. I'm going to click on OK, and that shows up here. next thing I'm going to do is match the raw data with this. So with this flow, we see we have the raw data, and it's going to remove normalized losses column from this data. Next thing I want to do is clean any missing data that we have. So I'm going to search for clean data. There we go. Clean missing data. I will drag that out here also. So after I drag the clean missing data variable out into the field, and the properties is where I can select what I want to do with any cells that have missing data. I can substitute it with a specific value, or I can substitute it with a mean, median, mode, etc. Or I can remove the entire column, or I can remove the entire row. So for this example, what I'm going to do is remove the entire row, and I'm going to link this data set with clean the data. So now we have the flow of the raw data. We're going to remove one column, and then we're going to clean the data set. And at this point in time, what I'm going to do is click on run. Now, why did I run the experiment now? So basically, by running the experiment, the column definitions for our data pass from the data set through the columns in the dataset module and through the clean missing data module. So this means that any modules we connect to clean missing data will also have the same information. So this is basically a cleaned version of our raw data. So anything that goes below this will start using this cleaned version. So that's why, again, I always do this as a preference, but you don't necessarily have to do this. So after we've done that, so our data is cleaned up and defined, the next thing, or the next step in machine learning is defining the features. So features are individual measurable properties of something that we're interested in. So in our data set, each row represents one automobile, and each column is a feature of that automobile, such as 4 doors, automatic, manual, and so on. So finding a good set of features for creating a predictive model requires experimentation and knowledge about the problem that you're trying to solve. Some features are better for predicting the target than others. Also, some features have a strong correlation with other features and can be removed. So for example, if you're driving in a city, the miles per gallon used then as compared to the miles per gallon used in a highway are closely related. So we can keep one and remove the other without significantly affecting the prediction. So what we're going to do is build a model that uses a subset of features in our data set, because we can always come back and select a different set of features, because this is, again, an iterative process. We can go back and forth, and most of the time you will need to go back and forth to do that. So what I'm going to do is select a set of features. So what I'm going to do is select columns in the data set. I'm going to launch the column selector, and with the rules I'm going to include column names, and I want to include, in this analysis, I want to include only these columns because these are the set of features I believe are the best predictor of what the price should be in a vehicle. And again, this can be dependent on any product that you are trying to sell or that you're trying to go to market with. And again, sometimes you guys will see this red exclamation mark. This basically means if you put on it, the import data set is unconnected, because obviously there is no connection here. So what I'm going to do is just connect this data column. So once that's done, it basically produces a filtered data set containing only the features we want to pass through the algorithm. And that leads us to our next step, which is choosing the right algorithm for this experiment. So what we're going to do now is use our data to train the model, and then we'll test the model to see how closely it's able to predict the prices. Now, classification and regression are two types of supervised machine learning algorithms. Classification predicts an answer from a defined set of categories, such as color, and regression is used to predict a number. And since we want to predict a price, which again is a number, we'll use a regression algorithm. So for this example, we are going to use a simple linear regression model. And we're going to train the model by giving it a set of data that includes the price. The model scans the data and looks for correlations between an automobile's features and its price. And after we've done that, we're going to test the model to see how accurately it is predicting the price. And one thing we're going to do is use our data for both training the model and also for testing it by splitting the data into separate training and testing data sets. Because the reason you want to do that is because with this you can kill two birds with one stone. This will not only train the model, but you will also see if the variables that you have set here and the regression model that you're using accurately predicts the data that you want to predict. Because you don't want to train the model and then find out later on that it's actually a wrong model. So this way we can train and see if it's correct at the same time, and if it's not predicting properly, we can always go back and use a different type of a logarithm. So what I'm going to do is split the data. So this column I'm going to split, and in the split data again we can choose if you want to split it 50-50, if you want to split it 60-40. What I'm going to do is split it 75-25. So we'll use 75% of the data to train the model and then 25% of the data for testing it to see if it's working properly. So I'm going to do 75%. So again, after I run the model, you guys can see that there's checkboxes all down here. So it's basically completed our experiment down to here, down to splitting the data. So it's got the raw data, we've removed a column, we've cleaned the missing data, we're using a subset of features, and we've also split that subset of features into 75 for training and 25 for testing. So now what we want to do is select the type of algorithm that we want to use. Just to give you guys an overview in terms of what different algorithms are available, if you click on machine learning, you guys can see all of the different algorithms that are available for you to use. What we want to use is a simple linear regression. This is the algorithm I want to use, and the next I want to also train my model. So I'm going to search for train model, and in training my model I want to use the linear regression algorithm, and this is the data that I want to use. Once we have trained model, we can use a column selector in the properties pane, and this is basically what we want to train a model for. What are we trying to predict? And again, as I said in the beginning, we are trying to predict the price that we want to sell our vehicle for. So I'm going to put that in this column. So again, we're training our model to use linear regression to predict the price. So after I've done that, I'm going to run the experiment again. And again, when you guys see the hourglass, it means it's basically running the experiment. Depending on the size of your data, that could take some time. But again, since we have a very small subset of data just for this demo, it works fairly quickly. So now that we've trained the model using 75% of our data, we can use it to score the other 25% of data to see how well our model functions. So what we're going to do is find a score model and drag that out into the field, and use the other 25% of the data that we split and use it for scoring the model. And then finally, we're going to run the experiment for the last time. So once that's done, what we've done is we've trained the model, and we've also scored the model to see how accurately it's been trained to predict the price. And the last thing we want to do is evaluate our results. So I'm going to click on Evaluate Model, drag that out into the field, and connect the output of the score model into the input of the evaluation model, and run the experiment to finally complete the evaluation. And once that's done, what we want to do is see the results. So we click on the output port and click on Visualize. It will give us a visual depiction of the results. So the following statistics are shown for our model. It gives us a mean absolute error, a root mean squared error, a relative absolute error, a relative squared error, and a coefficient of determination. And if you guys are not familiar with these terms, these are generic statistical terms, and as a very good homework assignment, please look these up and get a meaning of what these actually mean, so you can be familiarized with what these numbers actually stand for. Each of these error statistics, obviously smaller is better. A smaller value indicates that the predictions more closely match the actual values. And for the coefficient of determination, the closer its value it is to 1, the better the predictions. And as you guys can see, it's 0.91. So now that we have our first completed machine learning experiment, we can use it to continually improve the model and then deploy it as a predictive web service. We can keep changing the features we see in our prediction, because as you guys remember, I selected a subset of features that are available in each vehicle. We can use a different subset of features to see if the prediction is better using those features as compared to the ones we've used now. So again, it's a continually changing process. It's an iterative process, and we'll want to make sure that we keep doing that in order to get a optimal model that we can use for predicting the price of each vehicle. So thank you guys again for joining me for this tutorial where we ran through a sample experiment. I look forward to welcoming you back for the next lesson.